This video is for the second half of section 1.6. The problems that I'm going to draw from are on page 57. And again, I encourage you to read through the section there. The stuff on multiplying and dividing rational expressions is on pages 53, 54, and 55. So again, when we talk about rational expressions, what we're talking about is algebraic fractions. Okay, so let's review a little bit for multiplying and dividing regular fractions, and then we'll talk about how to do that with algebraic fractions. So if we're going to multiply two fractions, let's say we want to multiply 1/2 times 3/5. The idea is that we multiply straight across the top. 1 times 3 is 3. Multiply straight across the bottom. 2 times 5 is 10. And so our answer is 3/10. There are some reasons for why we do that. I'm not really going to go into them right now because I don't think that they're helpful to understanding the concept. If anybody's interested, I'd be happy to talk to you about it. So what happens sometimes though, so this answer is in lowest terms, okay? Now what if we had something like 1/2 times 2/3? Then we would get 2 on top, 6 on the bottom, and that's not in lowest terms, so we would want to reduce that to 1/3. Now, what frequently happens, and this is less important when we're working with numerical fractions, is that you can actually cancel before you do the multiplication. So we'll do it to this problem, and then we'll look at another one in a minute as well. So the idea here is that the 1 times 2 is just going to be on the top. The 2 times 3 is going to be on the bottom, so why don't we just cancel out these 2's before we actually multiply, and then that'll save us a little bit of work. Another example we could use would be something like 3/7 times 14 over 15. Now again, we could multiply these out. I think this would give us, 42 over 105, but notice it's less clear at that point what our common factors are, right? So why don't we cancel before we build these numbers up, right? We could say this is 3 times 14 on top, 7 times 15 on the bottom, 7 goes into 14 twice, 3 goes into 15 5 times, and so in the end, this is equal to 2/5. And that way we don't have to recognize the common factors between 42 and 105. Okay, and if you recall from studying how to work with fractions, typically most people do the canceling before the multiplication. In other words, there's nothing wrong with just skipping that step and doing the canceling here and then going straight to the answer 2/5. Okay, so let's see how that plays out when we're working with algebraic fractions. It's actually even more important. So let's look at a couple examples here. These are on page 57. Let's see here. Problem 16. We start out with 4a squared minus 4a minus 3 over 8a plus 4a squared, and then we want to multiply that by 16a squared over 4a squared minus 6a. Okay, so just like we did in the first part of this section where all we were doing was reducing fractions, we want to know what are the factors of each numerator and each denominator. This one right here is all multiplication. Okay, so we don't really need to worry about factoring that. This is already written in terms of multiplication. Down here, we've got a common factor of 2a. And so we can rewrite this as 2a times 2a minus 3. Over here, let's see. Looks like there's a common factor of 4a. Let's see here. And so then if we factor out that 4a, we'll be left with 2 plus a inside the parentheses. This is the only one that really involves a significant amount of work in terms of factoring. Let's see. Well, the 3 is prime, so it has to be 3 times 1. For the 4, we've got a choice of 4 and 1 or 2 and 2. Let's try the 2 and 2 first. 2a and 2a. And let's see, we want a negative 4 in the middle. So that means we can make that negative 6a, positive 2a. That gives us negative 4a. Okay. Something that you can do with these problems, it's not a guarantee by any means, but if you see something like this in the denominator, that might be a hint that it's more likely to have a 2a up here than it is to have the 4 times 1. And I'll talk about that more as we go through these problems. Let's see here. So the 2a minus 3's cancel each other out. Let's see here. This a and this a cancel out this a squared. Let's see, 4 goes into 16 4 times, and then 2 goes into 4 twice. And let's see, is there anything else hanging around? It doesn't look like it. So on top, we're left with 2 times 2a plus 1. And on the bottom, looks like everything got canceled out except for 2 plus a, or a plus 2. Now, again, I can't stress this enough, these 2's do not cancel. This 2 is a factor. It could cancel with another 2 that is a factor. This 2 is not a factor. It's being added to the a, and so that's why we can't cancel it out. So this is lowest terms for problem 16. All right, let's see here. Let's look at problem 18. So, problem 18, we get 2x squared plus x minus 3 on top, and x squared minus 1 on the bottom, and then times 2x minus 2 over 2x squared plus 5x plus 3. Okay, so I'll focus on doing what I think are the easier factorizations first and save the tricky ones for last. So here, 2x minus 2, you've got a common factor of 2. After you factor it out, you'll be left with x minus 1. Over here, this is a difference of squares, and this factors as x plus 1 times x minus 1. And right away, if you wanted to cancel out these x minus 1s, you could. There's nothing wrong with that. Let's see here. Now this one, we don't have a whole lot of choices. We've got a 2 here and a 3 here. In both cases, they're both going to factor as prime numbers, right? They're both prime numbers, so we don't have a choice. This has to be 2x times 1x, and this other one has to be 3 times 1. Now if I put the 3 here, notice how it's going to get multiplied by the 2 to give us 6, and then we won't get a difference of 1 for that middle term. So we need to switch those up. So there's a 3 here and a 2 here. So we want the 3 positive and the 2 negative. And then down here, similar scenario. We want these to add up to 5. So again, if I put the 3 here, that'll give us 6. That's already more than 5. And so we just want to split it up like this. So the 2x plus 3's cancel. These x minus 1's cancel. And so on top, we're left with 2 times x minus 1. And on the bottom, x plus 1 times x plus 1. Or anything that is equivalent to this. You know, this is also a correct answer because they're the same thing. Okay, so that's problem 18. Now let's look at a couple of division problems. So first, let's talk about dividing fractions. This is kind of an interesting topic. Let's see here. So what if we wanted to divide a couple of fractions? Let's say we wanted to divide, 2/3 divided by 5/7. Okay. Whether you know this rule or not, the rule for dividing fractions says take the fraction you're dividing by and multiply by its reciprocal. Okay, and that would give us 14 over 15. I've heard some people say keep, change, flip. If that helps you to remember how this works, that's fine. There's nothing wrong with that. Let's talk about why we do that and where this comes from. There's a couple different ways we can think about that. Okay? One way we can think about that is, you may or may not know this, but the fraction bar means divided by, right? Because how do you turn a fraction into a decimal? You do 2 divided by 3. That's what the fraction bar means, is divided by. So this division problem, we could actually write it like this. 2/3 divided by 5/7. Okay. That's the first step. Now that we've got a fraction here, right, we can multiply this by 1 and not change its value. Okay. And because it's a fraction, we can multiply by any form of 1 that we want to, right? Like 3 over 3, or 10 over 10, just like when we're making common denominators, which we'll talk about in the next section, right? We're multiplying by a form of 1, so we're not changing the value of this fraction. Well, here's the form of 1 I'm going to choose to multiply by. 7/5 over 7/5. Why am I going to choose that one? Well, on the top, I get 2/3 times 7/5. What do I get on the bottom? 35 over 35. That's 1. And so this is 2/3 times 7/5. So there's one reason why, if you want to calculate division of fractions, you can multiply by the reciprocal of the second fraction. Okay? There's one explanation why that works. Let's look briefly at a second explanation. Let's see here. So if we do division, let's say we do 10 divided by 5 equals 2, and we know that that's true because 2 times 5 equals 10, right? Okay. So let's do that with the fractions again. Let's see here. What were we working with? We were working with 2/3 divided by 5/7, right? Okay. Well, so we want to know what that's going to be equal to. We solved the problem already. We know that it's 14/15, but let's pretend that we don't know that. Okay. Well, whatever this number is, when we multiply it by what we were dividing by, 5/7, that should be equal to 2/3, what we were dividing into, right? Okay, well, let's build an answer here that replaces this question mark. Well, the idea here is that we need to replace this 5 with a 2, so part of what this answer is going to be should cancel out the 5 and then replace it with a 2. And then also we want to cancel out the 7 and replace it with a 3. So we can cancel out the 7 by putting a 7 on top, and then we'll get a 3 on the bottom by putting a 3 down there. So notice that this question mark is equivalent to 2/3 times 7/5, right? That's what we were just saying, is take the reciprocal of the second fraction and multiply it. Okay, so there's why we multiply by the reciprocal when we're dividing by a fraction. And you can do that with a whole number division as well. You can multiply by the reciprocal of 5 and get the same answer. It's not special to fractions. It's actually the definition of division mathematically. Okay, so let's look at some division problems. So let's see here. For example, problem 22. We start out 2a squared minus 5 2a minus 3. And then on the bottom, 4a squared plus 2a. And then, oh, right, this is division. I mean, we're going to switch to multiplying in a minute anyway, but just get us started all right. Divided by 2a plus 1 over 4a. Okay, well, the first thing we need to do is to rewrite this as a multiplication problem. So times 4a on top, 2a plus 1 on the bottom. So there we go. If you want to skip this step and just go right to this, I frequently do that myself, okay? So now it's just a multiplication problem, and we need to question what are the factors on the top, what are the factors on the bottom. Here, these are both prime, really, right? They can't really be broken down. So over here is where we need to do most of the work. Let's see. We've got a common factor of 2a here. And then this will leave us with 2a plus 1. Let's see here. So this is similar to what we were doing in those previous problems. The 2 and the 3 are both prime. We've just got to get them lined up to get a difference of 5 in the middle. So this time we really do want the 3 to be here because that'll give us 6 minus 1 gives us 5. We want the 6 negative. We want the 5 positive. So let's see here. So these two cancel. These a's cancel each other, and then 2 goes into 4 twice. And I think that's it. So on top, we're left with 2 times a minus 3, and then on the bottom, 2a plus 1. And again, can't cancel those 2's because this 2 is not a factor of the bottom. Okay, the only thing that would cancel this down here is another 2a plus 1. Okay. So that's problem 22. Let's look at a couple more. Okay, problem 24. We've got x squared plus 7x plus 10 over x squared minus x minus 30. And then I'm just going to write this as multiplication. Times, and then we put the 9x squared minus 1 on the top, and the 3x squared plus 7x plus 2 on the bottom. Okay. So now we're working with a multiplication problem. It started out as division, but we rewrote it as multiplying by the reciprocal. Let's do the simple ones first. This is x plus 5 times x plus 2. This one, we need factors of 30 that have a difference of 1. So that's 5 times 6. Okay. This is a difference of squares. So it's 3x plus 1 times 3x minus 1. And then this one again, you've got the 2 and the 3. They're both prime. We just want to set them up so that we can add up to get 7 in the middle. To do that, we'll want the 2 here because that'll give us 6 plus 1 makes 7. All right, so let's see here. The 3x plus 1s cancel each other out. The x plus 2s cancel each other out. And also the x plus 5s as well. So on the top, all we're left with is 3x minus 1, and on the bottom, we're just left with x minus 6. Okay. All right, let's look at one more here in section 1.6. So, problem 26, we start out with 9x squared plus 3x minus 2. And then on the bottom, 12x squared plus 5x minus 2. And then again, I'm going to rewrite this as multiplication by the reciprocal. So this will be 8x squared minus 10x minus 3 on top, and then 9x squared minus 6x plus 1 on the bottom. So these factorizations are a little bit tricky. They're a little bit harder than I would normally give, but you know, this is not a timed situation when you're working on these problems in the textbook, so I don't feel bad about doing that. I think it's good to put in a little bit of work. I try to ease up a little bit if we're working on a test where you're timed. Let's see here. Well, let's start with this one right here. None of these is really appealing in terms of getting the easy ones out of the way. So let's just start with this one right here. The 2 is prime. We don't have a choice. It has to split up as 2 times 1. Now, the 9 could be 9 times 1. It could be 3 times 3. Let's start with the smaller factors first. We'll try those out. This will be 6. That'll be 3. 6. Those have a difference that's equal to 3. So we want the 6 here to be positive, and we want the 3 there to be negative, and that would give us a difference of positive 3. So let's try the same thing down here. Put the 2 and the 1 in there, and this time we want a difference of 5. Well, let's see here. If we start with the 3 and the 4, there's 8 minus 3 is 5. Wow. I just got lucky on that one. But I do encourage you to try the smallest factor pairs first, right? With the 12, you could have 1 times 12, 2 times 6, or 3 times 4. It's more likely to be the smaller factor pairs. They're more common in these types of problems than the larger factor pairs. It doesn't work every single time, but it can save you a little bit of work. Let's see. So we want the 8 positive in this case to get a positive 5 out of that, and then we want the 3 negative. All right, let's keep going here. The 3 is prime. We don't have a choice. It has to be 3 times 1. And then we want those 2 multiplications to have a difference of 10. So 4 times 2 makes 8. So if I put them in here, there's 6 minus 4 is 2. So that doesn't work. But before I move on, let's swap these and put the 2x here and the 4x here, because now this will be 12 minus 2 makes 10. That's what we want. We want the 12 negative. We want the 2 positive. Okay. Down here, the 1 and the 1 have to split up. You don't have a choice. 1, it has to be 1 times 1. And again here, let's try the 3 times 3 first, and then that'll be 3 plus 3 makes 6, and if those are both negative, then that'll be the factorization. Okay, so now we've gotten that out of the way here. Let's see. The 3x plus 2's cancel each other out. The 3x minus 1's cancel each other out. And then I think that's it. So we're left with 2x minus 3 times 4x plus 1 on top. And then 4x minus 1 times 3x minus 1 on the bottom. And then that would be lowest terms. Okay, so that's it for section 1.6. In the next video, we'll get into section 1.7, which will also split up into 2 pieces. And that will be about adding and subtracting algebraic fractions. So we'll see you then.